Here we are going to do the sand testing practical under the module Metal Casting and Powder Metallurgy. Sand is the principal molding material in the foundry shop used for all types of casting, whether the cast metal and alloy are ferrous or non-ferrous. That is because molding sand possesses the properties desirable for foundry purpose. The principal ingredients of molding or foundry sand are silica sand grains, clay, here it is bentonite, and moisture. Each constituent is important in determining the properties of molding sand. Here we perform several tests to measure properties of foundry sand that include moisture content, permeability, compressive strength, shutter index, AFS sieve analysis, and AFS clay content. Firstly, we have to dry the foundry sand at 110 Celsius for about 2 hours to remove mechanically bonded water. After that, we prepare samples to measure moisture content, permeability, compressive strength, and shutter index. First, take 5 samples from dried foundry sand. Weight of one sample is 300 grams. Then add different amount of water to them, starting from 10 milliliters, then 15, 20, 25 and 30 milliliters. For the ease of use, you can label those 5 batches as sample 1, sample 2 like that. Here you can see the dried foundry sand and prepared sample 1 by adding 10 milliliters of water to 300 grams of dried sand. To measure the moisture content, take 50 grams from each sample which you have prepared, then oven them at 110 Celsius for 2 hours. Using this equation, you can calculate the moisture content. Now we add measured 50 grams of sand to these labeled 5 dishes from each 5 samples which were prepared by adding different amount of water. Then keep them in oven at 110 Celsius for 2 hours. Here you can see the final weight of each sample. Using this data, you can calculate the moisture content. Permeability and compressive strength. Permeability gives an idea about how well sand can bend. If higher the permeability, there should be more open structure in rammed sand. It goes to rough casting. If particles are tightly packed, it means permeability is low. That goes to generate pinholes. Compressive strength is the ability of a structure to withstand loads that tends to reduce the size. To measure the permeability and compressive strength, we prepare standard test specimen, which is a cylindrical shaped one with 2 inch in diameter and 2 inch in height. This specimen tube is used to prepare the test specimen. AFS standard rammer is used to make the specimen with standard size. First, measure the 165 grams of sand from one sample. Incorporate sand into the specimen tube. Then ram 3 times using this. After ram 3 times, top of the plunger shaft should be leveled with the center line on the tolerance plate when the height of the test specimen is exactly 2 inch. If not, you should repeat this by increasing or decreasing the weight until plunger shaft level with the center line on the tolerance plate. This permeability meter is used to measure the permeability and spring balance machine is used to measure the compressive strength. 165 grams of sand added specimen tube is placed on the stage of the AFS rammer. Then ram 3 times. After ram 3 times, top of the plunger shaft should level with the center line of the tolerance plate to get the 2 inch height specimen. We have to repeat this procedure by increasing or decreasing the weight of sand until we get the exact height for the specimen. This is the standard specimen. Now we are going to measure the permeability of the prepared specimen. First we have to get the indicator to the 0 position. Then place the contact head on the specimen. From this permeter you can read the permeability. Then same sample is used to measure the green compressive strength. Place the sample on the sample holder of the spring balance machine. Then we rotate the hand wheel in a clockwise direction until specimen collapses. Then you can read the strength of the specimen. Same procedure you should follow for the remaining 4 samples also. These are the permeability and strength values that we have measured for prepared 5 samples. Shutter index. Shutter index gives an idea about moldability of sand. For this also we use AFS standard runner. Using this equation you can calculate the shutter index for a required sample. When we prepare a test specimen to measure the shutter index of a sample, starting from 140 grams of sand, you can follow the same procedure which we followed to prepare the specimen to measure the permeability. This shutter index tester is used to measure the shutter index. Prepared test specimen with the specimen tube is located to the shutter index tester. When we pull the handle, sample falls onto the steel anvil cap. Distance between the anvil cap and the sample holder is 6 feet. Then we collect the sand remaining on the sieve and weigh. Here you can see the initial weight of the standard specimen and weight of the sand remaining on the sieve. Using this data, you can calculate the shutter index of the sand sample. AFS sieve analysis. Sieve analysis gives an idea about particle size distribution. First measure 50 grams of dried sand. Then we set sieves such a way that from bottom to top mesh size should be increased. Bottom one is the pan. Then we place measured sand on top sieve and shake 15 minutes using mechanical shaker. After that you can measure the weight of the sand remaining on each sieve. Here you can see the measured 50 grams of dried foundry sand and mechanical sieve shaker. First measure 50 grams of dried foundry sand. This is the mechanical sieve shaker. First we set the sieves and then set them to the sieve shaker. Then place sand onto the top sieve. Shake for 15 minutes. After 15 minutes, we measure the weight of sand remaining on each sieve. This table shows the weight of the sand remaining on each sieve. Using this data, you should plot cumulative weight versus mesh size graph. A. Fes clay content. First measure 50 grams of dried foundry sand. Then place it into the wash bottle. Add 475 liters of distilled water and 25 milliliters of NaOH. Then agitate 5 minutes using mechanical stirrer. Dilute it with water to a height of 6 inch and keep to settle for 10 minutes. Then remove 5 inch of water using a siphon tube. Dilute again to 6 inch level and let it to settle for 5 minutes. You should repeat this step 6 and 7 until water is clear. Here you can see wash bottle, measured distilled water and NaOH. First measure 50 grams of dried sand and place to the wash bottle. Then add 25 milliliters of NaOH and 475 milliliters of distilled water. Then agitate 5 minutes using mechanical stirrer. Dilute with water to a height of 6 inch. Then keep it settle for 10 minutes. After that, remove 5 inch of water using a siphon tube. Again dilute to 6 inch level and keep settle for 5 minutes. After that, remove 5 inch of water. You should repeat this procedure until water is clear. After the water is clear, remove sand and dry it at 110 Celsius for about 2 hours. Then measure the weight. Using this equation and the practical data, you can calculate the AFS clay content. For the calculation part of your coursework, you should do these things. For the discussion part of your coursework, these things should be added. That is about your practical